What does a mirror reverse?
If you look in a mirror, you seem to see yourself reversed left to right. Your left eye appears to be your right eye in the mirror. Yet the vertical direction is not reversed. Your chin is still at the bottom of your face.
What is the Faraday's law?
An electric field is produced by a changing magnetic field. The field can cause a current in a wire.
How can energy be transferred?
Any energy transfer involves a source, whose energy is reduced. A means of transferring the energy, and an energy receiver, whose energy is increased. It's convenient to use a diagram to keep track of the source, the transfer, and the receiver, see pages 61 to 62. For example, if a moving pool ball collides with another ball, it can transfer all or part of its kinetic energy to the other ball. Transfer of energy by this kind of mechanical interaction is called work. The moving ball does work on the stationary ball and its kinetic energy is reduced. The kinetic energy of the stationary ball is increased by the work done on it. When a slingshot does work on the stone, its stored elastic energy decreases and the kinetic energy of the stone increases. When you throw a ball, your stored chemical energy is reduced. Work is done on the ball, and the ball's kinetic energy is increased. Other methods of transferring energy that do not involve work will be discussed later.
Can displacement be defined in more than one dimension?
More often than not, you have to define a displacement in 2 or 3 dimensions. As an example, suppose you want to locate a house that is 160 feet west of 1st Avenue and 200 feet north of Main Street. The displacement is a combination of 160 feet west and 200 feet north.
How does the human eye see?
The eye is really an extension of the brain. It consists of a lens to focus the image, an iris to regulate the amount of light entering the eye, and a screen called the retina. The cells of the retina do some preliminary processing of the information. They receive then send signals along the optic nerve to the brain. The cornea is a transparent membrane on the outer surface of the eye. Between the cornea and lens is a fluid. Light refracts when going through the convex surface of the cornea into the fluid. In fact, most of the focusing of light in the eye occurs at the cornea. Light passes through the iris that opens and closes in response to the amount of light entering the eye. The iris can only change the amount of light to a going through it by a factor of 20. While our eye can respond to differences in light level of 10 trillion. The major task of the iris then can't be to control light intensity. In addition, when the opening in the iris shrinks, the eye can keep objects in focus from a wider range of distances. After passing through the iris, the light goes through the lens. The lens consists of layers of transparent fibers covered by a clear membrane. In order to focus in on objects that we want to see, our eye changes the shape, and thus the focal length of the lens and cornea by contracting or relaxing the ciliary muscle around the eye. Light then passes through a liquid called the vitreous humor that fills the major volume of the eye and falls on the retina. The cornea and lens have created an inverted image on the surface of the retina. The retina is composed of a layer of light-sensitive cells, a matrix of nerve cells, and a dark backing. There are two kinds of light-sensitive cells, cones and rods. The 7 million cones are sensitive to high light levels and are concentrated around the fovea, the part of the retina directly behind the lens. Surrounding it are some 120 million rods that are sensitive to low light levels. The entire retina covers about 5 square centimeters. There aren't 127 million nerves in the optic nerve that goes to the brain. So a system of nerves in the retina do some preliminary processing of the electrical signals produced by the rods and cones before sending the results to the brain.
What is a standing wave?
Two waves of same frequency moving in opposite directions produce a standing wave that appears to stand still.
What is dark energy?
For the first 10 billion years of the existence of the universe, the attractive forces of gravity on matter, both ordinary and dark, slowed the expansion of the universe. But beginning about 5 billion years ago, the universe began to expand at an increasing rate. Two studies of supernovae have documented this acceleration. The cause of this expansion has been called dark energy, but the nature of dark energy is totally unknown. It interacts only via gravity and is very dilute. One possibility is that Einstein's general relativity has to be modified by the addition of a cosmological constant. Einstein himself considered such a constant, then discarded it, calling it his biggest blunder. The problem with such a constant is that particle physics estimates the value, in proper units, of 1. But the value required to explain the extra expansion is 10^120. This huge discrepancy cannot be explained.
What are the types of simple machines?
There are four major groups of simple machines, levers, including wheels and axles. Pulleys, including gears, and the inclined plane, including wedges and screws.
What is a Fahrenheit scale?
Temperature scale on which the freezing point of water is 32 degrees Fahrenheit and the boiling point 212 degrees Fahrenheit.
What is plastic deformation?
Object's shape changed after deforming force is removed. See elastic deformation.
How could you define your position on Earth?
If you use a GPS device, you might find that your location is given as a latitude and longitude. For example, it might give you latitude 40 degrees 2628.43 N and longitude 80 degrees 0034.49 W. Note that these are angles, not distances. The reference for latitude is Earth's equator. The reference for longitude is the prime meridian that runs through Greenwich, England, a suburb of London.
What is an image?
Suppose light falls on your face. Light is reflected diffusely from this surface. That is, it is reflected into a wide variety of directions. Consider a very tiny object, like the end of an eyelash. Light from that point will leave in many directions. That point is called an object. An optical device can cause the light rays from the object to converge again to a single point. That point is called the image.
How can athletes use angular momentum?
Let's explore two different sports. In platform diving, a person pushes off the tower, and thus the platform exerts a force on her, Newton's third law. But, if she isn't standing straight up, the force also exerts a torque on her, and starts her rotating. If she pulls her arms and legs in, then her mass is closer to her axis of rotation, and her speed of rotation increases. To slow this rotation, she can extend her arms and legs. With good timing, she can hit the water with a bare minimum of rotation. Consider a figure skater. She can start spinning on the point of one skate by pushing on the ice with the second skate. Again, the force of the ice exerts a torque, and so her rotational speed increases. She can extend her arms to slow the rotation, or pull them in as close as possible to attain the highest spin rate.
What contributions did Aristotle make?
Aristotle was a Greek philosopher and scientist who lived for 62 years in the 4th century B.C.E. He was a student of Plato and an accomplished scholar in the fields of biology, physics, mathematics, philosophy, astronomy, politics, religion, and education. In physics, Aristotle believed that there were 5 elements: earth, air, fire, water, and the 5th element, the quintessence, called ether, out of which all objects in the heavens were made. He believed that these elements moved in order to seek out each other. He stated that if all forces were removed, an object could not move. Thus motion, even with no change in speed or direction, requires a continuous force. He believed that motion was the result of the interaction between an object and the medium through which it moves. Through the 3rd century BCE and later, experimental achievements in physics were made in such cities as Alexandria and other major cities throughout the Mediterranean. Archimedes, c. 287–c. 212 BCE, measured the density of objects by measuring their displacement of water. Aristarchus of Samos is credited with measuring the ratio of the distances from Earth to the Sun and to the Moon, and espoused a sun-centered system. Eratosthenes determined the circumference of Earth by using shadows and trigonometry. Hipparchus discovered the precession of the equinoxes. And finally, in the 1st century CE, Claudius Ptolemy proposed an order of planetary scientists disappeared. In the 800s, the rulers of the Islamic Caliphate collected as many of the remaining books as they could and had them translated into Arabic. Between then and about 1200, a number of scientists in the Islamic countries demonstrated the errors in Aristotelian physics. Included in this group is Al-Hazan, Ibn Shakir, Al-Biruni, Al-Hazini, and Al-Baghdadi. Mainly members of the House of Wisdom in Baghdad. They foreshadowed the ideas that Copernicus, Galileo, and Newton would later develop more fully. Despite these challenges, Aristotle's physics was dominant in European universities into the late 17th century.
What is pneumatics?
Use of a compressed gas rather than a liquid in a hydraulic machine.
What is a series circuit?
A series circuit consists of electrical devices such as resistors, batteries, and switches arranged in a single line. There is only one path for the charges to flow through. And if there is a break anywhere in the circuit, the current will drop to zero.
What is the first law of thermodynamics?
A restatement of the conservation of energy, net heat input equals net work plus change in thermal energy.
What is the island of stability?
All the isotopes of elements beyond lead are radioactive. Some have lifetimes of tens of millions of years, while others are fractions of a second. Nuclear physicists and chemists know that isotopes that have magic numbers of neutrons or protons are more stable than others. They have proposed that very heavy isotopes with a neutron number around 180 and a proton number around 110 should be more stable than those with fewer or greater neutrons and protons. A glance at the table of elements beyond uranium shows that elements around 110 have longer lifetimes than others. But researchers have not yet been able to create isotopes with enough neutrons to reach this island.
What does the fact that most galaxies are seen with a red shift mean to astronomers?
The fact that astronomers observe most of the galaxies in the universe as having a red shift means that overall, galaxies are moving away from our galaxy, the Milky Way. This can only be happening if the universe as a whole is expanding. The expansion of the universe led to the development of the Big Bang theory of the universe's creation.
What is a cornea?
A transparent membrane that contains the fluid in the eye.
How does a Leyden jar work?
A Leyden jar is an insulating container with conductors on the inner and outer surfaces. When charging the Leyden jar, the source of charge is connected to a rod touching the inner conductor while the outer conductor is connected to ground. The inner and outer conductors become oppositely charged. It takes energy to move additional charges to the jar as the charges overcome the repulsive forces of the charges already on the conductors. The jar stores this electrical energy. If the inner and outer conductors are connected by a wire, the charges flow and make the two conductors neutral again. The modern capacitor is an updated version of the Leyden jar consisting of two conductors and an insulator.
What is Carnot efficiency?
Largest efficiency that a heat machine can obtain. E equals, thought, cold, / thought. Cathode negative electrode or terminal on, E. G a battery, electrolytic cell, or cathode ray tube.
What is an image, Virtual.
Light rays do not converge, but your eye believes that rays came from a single point. Cannot be projected on a screen.
What is a chromatic aberration?
Defect of a lens that introduces colors into images.
What determines how much a material will bend?
Try to bend a ruler. Hold one end tightly on your desk and push down on the other end. You are exerting a tension force on one surface and a compressive force on the other. The amount the ruler bends depends again on the Young's modulus, Y, of the material as well as its length, L, width, W, and thickness, T. The bending, X, is proportional to the force applied, F, and the length cubed and inversely proportional to its thickness cubed. Or, in the form of an equation, X equals FL3/T3WY. That is why the joists supporting a floor are much thicker than they are wide. Typically wood 1-1/2 wide but 10 or 12 thick is used. The larger thicknesses are used if the span between supporting walls is longer. An I-beam is often used to support weight. The beam is in the shape of the letter I. The vertical member, tall and narrow, keeps it from bending while the top and bottom members keep the vertical member from twisting. While I-beams are most often made of steel, wood beams are now used in houses because they are stronger, lighter, and cheaper than steel.
What is mechanics?
Study of the effect of forces on the motion and energy of physical objects including fluids and granular particles.
What is active noise cancellation, ANC?
Device that creates a waveform that is the opposite of the noise so that the noise is cancelled.
What is the uncertainty principle?
Limitation to simultaneous knowledge of position and momentum of particle, dx dps equals h/4p. Equivalent equation for energy and time.
What is a torque, T?
Equivalent of force for rotational motion. If forces is at a right angle to the radius, then torque equals the force times the distance from the axis of rotation.
What is the modern conception of light?
As demonstrated by the work of Young, Poisson, and Fresnel, and later by James Clerk Maxwell, 1831 to 1879. And Heinrich Hertz, 1857 to 1894, light is an electromagnetic wave to which human eyes respond. It is located on the electromagnetic spectrum between infrared and ultraviolet. The limits of human vision define the lower and upper boundaries of light. The lowest frequency is 4x 1014 Hz, which has a wavelength of 700 nanometers, 700 x 10 to 9 m. Its upper boundary is 7.9 x 1014 Hz, a wavelength of 400 nanometers. Wavelength rather than frequency is commonly used when describing light because until the past 3 decades only wavelength measurements were possible. Light frequencies were too high to measure directly. Light has all the properties of a transverse wave. That is, it can transfer energy and momentum. It obeys the principle of superposition and can be diffracted and interfere with itself. On the other hand, it also has the properties of a massless particle. While in a medium it moves in a straight line at a constant velocity. It can transfer energy and momentum.
What is the Van Allen belt?
Donut-shaped regions of charged particles around Earth. Created by charged electrons and protons from solar wind and cosmic rays trapped by Earth's magnetic field.
What is the function of the grating on the door of a microwave oven?
People using microwave ovens want to see the food cooking inside the oven, yet not be bombarded by potentially harmful microwaves. In order to prevent the escape of microwaves through the plastic or glass door, a grating consisting of small holes is used to reflect the microwaves back into the oven. The microwaves, which have a wavelength of about 12 centimeters (4.7 inches), are too big to pass through the holes, but visible light, whose wavelength is smaller than the opening, can easily pass through the grating. Although the grating protects people from the microwaves, some microwaves can still leak out through the door seal, however, if it's not cleaned occasionally.
What is Kepler's second law?
In equal times planets sweep out equal areas.
What is the buoyant force?
from the equation obtained in the answer to the last question. You can see that when you place an object in water, its weight is reduced by the weight of the water displaced. The reduction in weight, object, weighter. That is the net upward force of the water, is called the buoyant force.
What is an ultrasonic sound?
Frequencies above human hearing, 20 kHz.
What is an insulator, electrical?
A material in which electrons are strongly bound to their nuclei and thus cannot move through the material.
What is an evaporation?
Change from liquid to gas at a temperature below the boiling point.
What is the Coulomb's law?
Describes the strength of the electrical force between two charged objects. F equals K, Chi Q2/R2.
What is condensed matter physics?
Studies the physical and electrical properties of solid materials.
What is a ramp?
Example of an inclined plane ma equals 4 foot/fin equals, length of ramp, / height of ramp.
What is a galvanic cell?
Combination of two different metals separated by a conducting solution. That produces a potential difference and thus a continuous flow of charge.
What is a pinna?
Outer ear. A cartilage flap that forms a transformer to match the impedance of the sound wave in air to that at the end of the ear canal.
How do earbuds use the results of electromagnetism?
An earbud contains a membrane made out of thin plastic. In the center of the membrane is a coil of wire called the voice coil. The coil fits in a cylindrical slot in a permanent magnet. The center rod of the magnet is one pole, the outside tube is the other. resulting in a magnetic field perpendicular to the wire. When there is a current through the wire, the Lorentz force on the wire pushes the membrane in and out. The membrane exerts forces on the air molecules, producing the longitudinal waves constituting sound. Refer to the sound chapter for more information.
What is the shape of a lens when focusing on objects far away and objects up close?
The ciliary muscle, responsible for changing the shape of the lens, adjusts its tension to focus on different distances. When focusing on objects far away, the lens needs a large focal length. So the muscle is relaxed in order to make the lens relatively flat. When an object is closer to the eye, however, a shorter focal length is needed. The ciliary muscle contracts, reducing the focal length of the lens by making it more spherical. The process of adjusting the shape of the lens to focus in on objects is called accommodation.
What is an electromagnet?
Coil of current carrying wire wound on an iron core that produces a magnetic field that depends on the current.
What is Kepler's third law?
The square of the period of the planet is proportional to the cube of the radius of the orbit.
Does light interact with an atom as a wave or a particle?
A wave carries energy continuously over time. The more energy in the wave, the faster the energy is transferred. A particle, on the other hand, delivers its energy all at once. When an atom either absorbs or emits light, the transfer is almost instantaneous. Therefore, light interacts with an atom like a particle. The idea that light comes in packets of energy was first stated by Albert Einstein. 1879 to 1955, in 1905. He called the packet a light quantum. The quantum was given the name photon in 1926. The photon has no mass or charge, but it does carry angular momentum. It always moves at the speed of light, c. Each photon carries an amount of energy E equals hf, where f is its frequency. Therefore, a photon of blue light has more energy than one of red light. The energy carried by a beam of light depends both on the frequency and the number of photons per second leaving the source.
What is subtractive color mixing?
As opposed to the mixing of light, additive color mixing. Subtractive color mixing occurs only when combining dyes, pigments, or other objects that absorb and reflect light. For example, you could shine white light through two colored filters or gels. Or, you can reflect light from colored surfaces. If you shine white light on a blue wall, the wall absorbs red and green but not blue. So if we know what colors are reflected, we know the color of the object. The primary pigments or dyes are magenta, which reflects blue and red light but absorbs green, cyan, which reflects blue and green but absorbs red, and yellow, which reflects red and green but absorbs blue. These are the same colors as the secondary colors obtained when mixing light. Note that if we combine magenta, cyan, and yellow, the red, green, and blue are all removed, leaving nothing, that is, black. Blue is light in the range of 400 to 500 nanometers. Green is roughly 500 to 560 nanometers. Yellow is 560 to 590 nanometers, orange 590 to 620 nanometers, and red beyond 620 nanometers. It may seem surprising that yellow filter transmits green, yellow, and red. But the eye is not very sensitive to red in comparison to green and yellow. That's the same reason that the transmission of the blue and indigo filters beyond 660 nanometers does not impact what the eye sees. Finally, note that purple is a mixture of blue and red.
What happens to the momentum of the ball and you and the chair altogether?
As long as external forces are zero or small, then in any interaction the momentum of the system, in this case the ball, U, and the chair will be constant. This result is called the conservation of momentum. The sum of the decrease in momentum of the ball and the increase in momentum of U and the chair will be zero.
What is the difference between physical and geometrical optics?
Geometrical optics deals specifically with the path that light takes when it encounters mirrors and lenses. Geometrical optics uses the ray model of light in which an arrow represents the direction light travels. The ray model does not consider the wave nature of light. Ray diagrams trace the path that light takes when it reflects and refracts in different media. Reflection occurs when light bounces off a surface, whether it is a piece of paper or a mirror. Shiny metals and very still water make good reflectors, creating images that resemble objects from which the light is coming. Physical optics, on the other hand, is the division of optics that depends on the wave nature of light. It involves polarization, diffraction, interference, and the spectral analysis of light waves.
What is colorimetry?
Measurement of the intensity of particular wavelengths of light.
Why do you need two connections at the ground potential?
Because when the appliance plugged in draws current, there is current through both the black and white wires. Each wire has resistance, so there will be a voltage drop across the white wire. And it will be above ground potential at the outlet. While this voltage will be small, it could be dangerous. The green wire, which carries no current, will remain at ground. It can be connected to the metal case of the appliance, assuring that the case will remain at ground potential. When installing an electrical outlet, note that the green wire. Okay, you can't tell in this black and white photo, but it is there. Is the grounding wire, which must be attached to the grounding contact on the outlet.
What is a reflecting telescope?
A reflecting telescope uses a mirror to gather light and focus the light toward the eyepiece. It usually consists of two mirrors, one large curved mirror at the end of the telescope to gather light and a smaller mirror used to direct the light to the eyepiece.
What is the weak nuclear force?
Cause of beta decay. Weaker than strong nuclear force. Shown to be an aspect of the electroweak force. Carried by the massive W+, W-, and Z degree particles.
What is an audion?
A vacuum tube amplifier invented in 1906 by Lee de Forest.
What did Benjamin Franklin's famous kite experiment prove?
Benjamin Franklin is probably most famous for flying kites in thunderstorms. In the mid-I-700s there were three different phenomenon that had similar effects. You could draw sparks with frictional or static electricity. Lightning appeared to be a giant spark, and electric eels could cause shocks like static electricity. But no one knew if these three had the same or different causes. Franklin touched a Leyden jar to a key tied to the string of his kite. When sparks jumped from the cloud to the kite, the charges went down the string and charged the Leyden jar. Thus Franklin showed that lightning and frictional electricity were the same. Benjamin Franklin did not discover electricity, but he did show that lightning and frictional electricity were the same thing with his famous kite experiment involving a key and a Leyden jar.
What is the electromagnetic spectrum?
The electromagnetic spectrum is the wide range of electromagnetic M waves from low to high frequency. The spectrum ranges from low-frequency radio waves all the way to gamma rays, which have a very high frequency. In the middle of the spectrum is a small region containing the frequencies of light.
How much does a moving clock slow down?
A clock on a jet plane, V equals 550 miles per hour, would lose 0.9 milliseconds per year. While one in the space shuttle, V equals 17,500 miles per hour, would lose 0.9 s/year. In 1971 atomic clocks were placed on planes, one of which flew around the world eastbound, the other westbound. The changes in time were measured and agreed with relativity theory. Clocks on GPS satellites must be adjusted for the loss of time. More conclusive tests have been done with very fast-moving, 0.995 c, muons. Muons, when at rest, decay in 2.2 ps, microseconds. The number of muons, produced high in Earth's atmosphere by cosmic rays, were measured at the peak and base of a high mountain. The ratio of numbers at the two heights showed that the muons lived 22 ps, which agreed with their measured speed of 0.995 c. From the viewpoint of the muons, they decayed in 2.2 ps. But the height of the mountain was 10 times shorter than that measured by observers on Earth. Thus the predictions of slower clocks and shorter distances have been tested and agree with Einstein's predictions.
Where did its kinetic energy go? What was the effect of the friction between the block and table?
To explore friction, rub a pencil eraser on the palm of your hand. Then quickly put the eraser against your cheek. You probably found that both the eraser and your hand became warmer. The friction between the block and table had the same effect. But the temperature change was probably too small to detect. If the temperature increases, then the thermal energy in the object has increased. Thus the decrease in kinetic energy of the block was AC accompanied by increased thermal energy in both the block and the table. The energy just changed forms. Scientists have made careful measurements of energy in a variety of forms and have always found that energy is neither created nor destroyed. In other words, the energy put into a system always equals the energy change in the system plus the energy leaving the system. These measurements have led to a law, the conservation of energy. As long as no objects are added to or removed from a system, and as long as there are no interactions between the system and the rest of the world, then the energy of the system does not change.
What is the Magnus force?
Force on a spinning ball that causes its path to curve.
How is a second measured?
Atomic clocks are the most precise devices to measure time. Atomic clocks such as rubidium, hydrogen, and cesium clocks are used by scientists and engineers. When computing distances with global positioning systems, GPS, measuring the rotation of Earth. Precisely knowing the positions of artificial satellites, and imaging stars and galaxies. The clock that is used as the standard for the second is the cesium-133 atomic clock. The measurement of the second is defined as the time it takes for 9,192,631. 770 periods of microwave radiation that result from the transfer of the cesium-133 atom between lower energy and higher energy states. The second is currently known to a precision of 5 × 10⁻16, or 1 second in 60 million years.
Why are there no commercial supersonic planes?
From 1973 to 2000, the Concorde was a symbol of fast and expensive air travel for business people. The plane was a fast but inefficient plane that could carry 78 passengers. The sleek, delta wing design and pinpoint nose, which tilts down during liftoff and landings, could achieve speeds of up to Mach 2.2 at 15,240 meters, 50,000 feet, above sea level. But an accident involving a landing wheel, which killed all 109 passengers and crew, grounded the Concorde. Over the next 16 months the plane was extensively renewed and tested. Unfortunately, the terrorist attacks on September 11, 2001, reduced the demand for fast flights.
What is rotational kinetic energy?
Equivalent of kinetic energy for rotational motion.
Do all relative velocities add?
Suppose you were riding on a spaceship moving at half the speed of light. If you were to point a laser in the direction the ship was moving, the person on the spaceship would be able to determine that the speed of the laser light was the speed of light, 300 million meters per second.
How is uranium enriched today?
Today ultracentrifuges are used for uranium enrichment. A centrifuge is routinely used in medical labs to separate materials of different density. The test tubes are spun rapidly and the denser materials move away from the center of rotation because it requires more centripetal force to pull them toward the center. A gas ultracentrifuge uses a rapidly rotating drum to separate the UF6 with the two isotopes. Gas centrifuges supply about 54% of the enriched uranium today. Each centrifuge is a more effective separator than a stage in a gaseous diffusion plant and requires only 6% of the electrical energy of gaseous diffusion.
Why is it better for a discus to be thrown into the wind instead of with the wind?
In most sports, throwing or traveling with the wind at your back, called tailwind, is a lot easier than working against the wind, called a headwind. In football, teams flip a coin to determine who will be kicking with the wind. In sailing, it is easier and faster to travel perpendicular to or with the wind and takes more skill to travel against the wind. In track, the world record in the 100-meter dash could more easily be broken if running with a strong tailwind. In most sports, having the wind at your back can be a major advantage. In the field event of discus throwing, however, the advantage comes when there is a headwind. In fact, it has been documented that a discus can travel up to 8 meters, 26 feet. Further, while experiencing a headwind of only 10 m/s, meters per second. Although the discus still experiences a drag force from the headwind, the lift that the discus gets from pressure differences over and under the disc is substantially more significant than the drag force. Because the discus will remain in the air longer, it will travel farther.
What are the secondary colors in subtractive color mixing?
The secondary colors for dyes and pigments are the same as the primary colors in additive color mixing. Red, green, and blue dyes or pigments reflect their own color while absorbing the other two colors. For example, red would reflect red but absorb the green and blue light.
What is a rainbow?
Spectrum of light formed when sunlight interacts with water droplets. Angle between entering and leaving is 40 degrees for blue light, 42 degrees for red.
What is a positron emission tomography, PET?
Method of forming three-dimensional image of human body. Uses a short-lived positron-emitting isotope inserted into a biologically active molecule.
How do the charged regions of clouds and the ground act as a giant capacitor?
A capacitor consists of two conducting plates with opposite charge separated by an insulator. When a wire is connected between the two plates, a large electric current flows the charges rapidly from one plate to the other, neutralizing the capacitor. The charged regions of the clouds act as conducting plates while the air between them acts as the insulator. The same thing occurs between the lower section of the cloud and the ground. The air between these sections acts as the insulator, but when the forces exerted by the charges on the air molecules are large enough, they can rip the electrons from the molecules. The result is a positively charged molecule, called an ion, and a free electron. The air is changed from an insulator to a conductor. The mobile electrons gain more energy, creating more and more ions and additional free electrons. When the electrons and ions combine again, light is emitted. The tremendous amount of energy released rapidly heats the surrounding air, producing thunder.
What is latent heat of fusion?
Energy involved in change from solid to liquid phase.
What happened to Democritus and Aristotle's ideas?
For almost 2,000 years Aristotle's philosophy was taught in schools and accepted by educated people. In the 16th century, doubts about Aristotle's science increased. A number of philosophers, including those whom today we would call scientists, actively opposed Aristotle's dominance of the curriculum in schools. Englishman Francis Bacon, 1561–1626, developed what we today would call the scientific method in opposition to Aristotle's philosophy. In 1612 Galileo, 1564–1642, published Discourse on Floating Bodies, in which he envisioned atoms as infinitely small particles, views that he later expanded in the Essay 1623, and, more completely, in Discourses on Two New Sciences, 1638. Nevertheless, the debate over whether atoms, much too small to see, really existed or were just a successful model of matter continued for another 2 centuries.
Why is a stone easier to lift when it is in water?
Even though the stone sinks because it is denser than water, there is still a buoyant force on it given by Ushtone, waiter, so the stone's weight is reduced. Floating usually refers to a liquid such as water, but can anything float in a gas? Remember that there is a difference in pressure of any fluid between the bottom and top of an object in it given by L bottom equals top plus pGh. Even though the density of a gas, P, is much smaller than that of a liquid, there is still a pressure difference, and therefore a buoyancy. There is another difference between a liquid and a gas. A gas can be compressed, and so the density of the atmosphere decreases as you rise. When a hot air balloon is launched, the air within it is heated and it will rise. As it rises, the density of the air decreases, and so the buoyant force decreases. At some height, the weight of the balloon and basket equals the weight of the air displaced, and the balloon stops rising. The operator of the balloon can go higher by making the gas in the balloon hotter, and thus less dense.
What is a strong nuclear force?
Force within nucleus that acts between protons and protons. Protons and neutrons, and neutrons, and neutrons, all with the same strength.
What is the diffraction of light?
Reflection and refraction use the ray model of light. But, when light goes through a very small opening, the ray model is no longer sufficient. The wave properties of light become important. Suppose you pass light through a round aperture whose diameter you can change. Let the light fall on a screen. As you first begin reducing the size of the hole, you'll find the size of the bright spot shrinking. But, when the hole becomes very small, a strange thing happens. The spot no longer shrinks, but its outer edge becomes fuzzy. Light begins to bend around the edge of the hole. Diffraction also occurs when light is sent through narrow slits, or if there are small objects that cast shadows in a broader beam of light. Diffraction occurs with all types of waves. You can often see it in water waves, and it is one reason that sound waves spread when they come through a door or window.
What is a third-class lever?
Simple machine with pivot at one end or bar, the effort force exerted at the other end. The input force between the two, ma less than 1.
What is a kilowatt, kW?
(1000 watts or 1000 joules per second).
Have you ever seen the bed of nails demonstration?
A large number of nails are pounded into a board that is about the size of a person's back. The person very carefully lies on the bed. Sometimes a second bed is placed on his chest. A concrete block is put on this bed, and a sledgehammer is used to shatter the block. The person is not harmed.
Why is it dangerous to look at a solar eclipse?
Looking directly at the photosphere of the Sun, the bright disk of the Sun itself, even for just a few seconds, can cause permanent damage to the retina of the eye. Because of the intense visible and ultraviolet rays that the photosphere emits. This damage can result in permanent impairment of vision, up to and including blindness. The retina has no sensitivity to pain, and the effects of retinal damage may not appear for hours. So there is no warning that injury is occurring. Under normal conditions, the Sun is so bright that it is difficult to stare at it directly. So there is no tendency to look at it in a way that might damage the eye. During a total eclipse, however, with the Sun covered, it is easier and more tempting to stare at it. Unfortunately, looking at the Sun during an eclipse is dangerous even if totality occurs only briefly. Viewing the Sun's disk through sunglasses or any kind of optical aid, binoculars, a telescope, or even an optical camera viewfinder, is extremely hazardous. The best methods are to use special solar filters, welder's glasses, or a pinhole camera.
What discovery did James Clerk Maxwell make that depended on the work of Ørsted, Faraday, and Ampere?
In an earlier chapter we have seen that charges create electric fields. In this chapter we have seen that moving charges, that is, currents, create magnetic fields and that changing magnetic fields produce electric fields. In the 1860s, Scottish physicist James Clerk Maxwell, 1831 to 1879, added a crucial additional connection. Changing electric fields can produce magnetic fields. With that idea, Maxwell recognized that these relationships meant that electric and magnetic fields could move through space. The fields move through space as transverse waves that are perpendicular to each other. Maxwell calculated the speed and found that it was equal to the speed of light. He published his results in 1864 and a textbook on electromagnetism in 1873. In 1881, Oliver Heaviside wrote Maxwell's famous four equations in the form they are used today. In 1888, Heinrich Hertz, 1857 to 1894, transmit electromagnetic waves across his laboratory, confirming Maxwell's theoretical work.
What is a kilocalorie, kcal or cal?
The food calorie used to measure energy content in foods.
How is nuclear fission used peacefully?
Nuclear reactors produce electric power. The energy from uranium fission heats water that circulates through the reactor. The heated water produces steam that turns turbines connected to generators. As is the case with all electric power plants, only about 1/3 of the energy produced by the reactor is converted into electrical energy. The remaining energy heats local rivers, lakes, or the atmosphere. In the United States there are 104 reactors that provide about 20% of the electricity used by our country.
What is carbon dating?
Method of dating objects by measuring relative amounts of radioactive and stable carbon in them.
Why is measurement so important for physics?
While Aristotle, 384 to 322 b. CE, emphasized observation rather than measurement or experimentation. Astronomy required measurements of the locations of stars and wanderers, now known to be planets. The study of light was another early field that began to emphasize experimentation and mathematics.
What methods are being used to reduce noise pollution?
Since noise creates stress and can lead to other health problems. Industries and governments around the world are working to reduce noise levels, especially around populated regions. One method of reducing noise pollution around airports has been rerouting airline traffic so that it passes over less populated areas. Sound barriers have been installed along many highways to absorb and slash or reflect sound away from houses built alongside the roads. In countries such as Austria and Belgium, roadways are being constructed with a material called whisper concrete that engineers claim reduces noise by 5 decibels. Finally, Swedish engineers have developed a road surface made of pulverized rubber that can reduce the noise level by as much as 10 decibels.
What is the modern-day version of a Leyden jar?
The capacitor is the modern version of the Leyden jar. Like the jar, it consists of two conductors separated by an insulator. The insulators used can be air, a thin plastic film, or a coating of oxide on the metallic surface. One use of a capacitor is to store the energy needed to fire a flash lamp on a camera. A battery-powered circuit slowly charges the capacitor. When the flash lamp is triggered, the capacitor's energy is quickly transferred to the lamp, creating a brief, intense flash of light. Capacitors are also used in electronic devices from telephones to televisions to store energy and reduce changes in voltage.
What are complementary colors?
Complementary colors are pairs of one secondary and one primary color that, when mixed, form what is close to white light. For example, Yellow and blue light are complementary because when combined, they form white light, as will magenta and green, and cyan and red.